This is the mini lesson on basic rational function graphs for Algebra 2, brought to you by Grace, Marie, and Michaela. What to expect in this mini lesson: a discussion of basic rational function graphs, simplifying rational expressions, adding/subtracting, or multiplying/dividing a rational expression, a real-life application of rational functions, and 2 practice problems. What is a basic rational function graph? This is the basic equation you're going to get, and it is the basic rational function. And then this is that equation on a chart, but with variables. And then, and then this is what it looks like on a graph. You're going to see the different points throughout the graphs. And then you're going to also see the vertical asymptotes. And you can see how they are both curved either down or up. And then you're going to see the range on over here. And then the domain would be usually across the graph, but I just didn't want to put that over the graph. And then I used the graphing basic rational functions video that was linked in our rubric for reference and examples, especially it really helped me out with these 3 bullet points, and then explaining and showing the vertical asymptotes. And then every time, like, the reciprocal gets smaller and smaller every time. So the vertical asymptotes are vertical lines that correspond to the zeros of the denominator of a rational function. As you can see here, they are the vertical asymptotes. And then the domain and range are these red lines. And the domain is a set of possible input values, so like the domain, and then the range is a set of possible output values, and the red is the domain and range, and the green is the vertical asymptotes.
Divided by x minus 2, subtracted by 2 divided by x plus 1. Step 1, you find the common denominator. In this example, you can create a common denominator by multiplying the first fraction by x plus 1 divided by x plus 1. The second fraction, you do it by x minus 2 divided by x minus 2. And you get this. You then subtract your problem and you simplify it to x plus 7 divided by x minus 2, x plus 1. A real-life application of rational functions. Your high school is organizing an event for your alumni. The planning committee decides to rent a room to get dinner catered. This space costs $600 for the night, and each dinner is an additional $20 per person. To honor the 5 oldest alumni, the committee will not charge them for dinner. Instead, their dinner will be included in their total cost to the committee. The committee wants to break even and not turn it to a profit.
In the next part of our lesson, we will be simplifying rational expressions. Recall that a rational function is a function f of x such that f of x equals p of x over q of x, where p of x and q of x are both polynomials. And the rational expression is just p of x over q of x. Label that. And like any fraction, a rational expression can be simplified. To simplify a rational expression, you will need to factor out the polynomials to determine if any factors are the same and then cancel out any like factors. So we will take the rational expression x squared plus 6x plus 9 all over x squared plus 8x plus 15. If we factor that out, we will get on the numerator x plus 3, x plus 3 over x plus 3, x plus 5. And then we will cancel out the common factors. So we have x plus 3 and x plus 3. So then this will be equal to x plus 3 over x plus 5. It's important to remember that x plus 3 over x plus 5 is completely factored and you should not cancel out the x's. Yes, 3x over 5x does reduce to 3/5, but x plus 3 over x plus 5 doesn't because there's an addition sign. In our next example, we have 2p plus 6 over the quadratic expression p squared plus 6 minus 6. So what I'm going to do is simplify this as much as possible, so we're going to factorize it, and factorize it in a way that we can cancel out something from the numerator and denominator. So we can pull a 2 out of the 2p and the 6, and then we'll have p plus 3 over. Now we will factorize out the denominators, so we will get p plus 3 and p minus 2. Remember to use the bigger number on the positive side. Now we have two factors that are the same, p plus 3 on the numerator and denominator, so we can cancel that out, and that leaves us with 2 over p minus 2, which is our final answer. And this is true if p is not equal to 0. You can also add that into your answer. Moving on, we will be talking about adding and subtracting rational functions. It's important that we first look at the steps for adding and subtracting rational functions before we solve them, just so we have an idea of what we will be completing. Okay, so steps required for adding and subtracting rational functions. Step 1 is to factor the denominator, and that will help you find the least common denominator. Step 2 is to find the least common denominator. Step 3 is to find the numerator for each fraction. Step 4 is to combine the fraction by adding or subtracting the numerators.